So that's what we would have seen largely before the break, okay? Now, the catch with this stuff is we also started to see yesterday with the crazy cab question, we started to see where we were plotting two different lines on one grid. So we would have seen, okay, there's one line, but we would have also seen another line, and they would have crossed at some point, right? That cross, or where those two lines meet, that is the X and Y that we were finding this morning, or what we called yesterday the point of intersection, right? So all these points down here, when you guys do this work, and I'll show you a little bit more of what that means now, okay? This, for instance, right here in this question, is the point of intersection. Okay, it would be what it is you're solving for with these answers. These are all points of intersections. Okay, X and Y's. Right, so for that particular question, which we'll look at now, okay, it's telling you where those two lines are crossing. So as you guys do these questions and you use the process that we did this morning, substitution, you know, you're going to write these as points of intersection. So where these two lines cross in number one, for instance, if you were to plot these, right, they're going to cross at 6 and 4. Okay? And for the reason that what I'm going to do now is to run back through this after you've had a little bit of context. So we're just going to jump back and forth so that you guys get a little bit more of an idea towards what it is we're actually using that substitution process for. Okay, so we're going to bounce back here. We're going to look at the meaning of the point of intersection. Sorry, I just got an email too from somebody. So here you have two graphs, okay? And then on it, and again, you guys can find this under the content under day 5, okay? So this is under the linear relations, or day 6, sorry. It'll be down here, point of intersection, okay? It's right here. So the point of intersection is a decision point, is basically what it is. And I think we talked about that yesterday with the cabs, right? So this graph is representing the cost to produce and sell pizza. Graph A represents the daily cost to produce pizza. Graph B represents the daily income from the sale of the pizza. So it's two different things. So how much it costs, one line is costs, and one line represents how much money they're making from selling the pizza, okay? So remember, you'll notice here, one of these does not start at 0, right? We're going to notice that this one here does not start at 0. Okay, it does not start at 0 for the reason that if you were to start up a pizza company or whatever, right, you're going to have to pay for some upfront costs, right, or whatever that might be, like dough or like creating the flour for the dough, or like the building, or your rent, or whatever it is, right? You're going to have some upfront costs. Now, what you're going to notice is the other one starts at 0 because in order to make money, or sorry, let's not word it like that. Well, in order to make any money, you're going to have to produce pizzas, right? So that, but you don't make any money if you haven't made any pizzas. That's where, so that's why it's going through 0, 0. Okay, it's kind of like a direct relationship. Every pizza you make money, right? But you're still going to have to like come out from underneath these costs, right? So if we look at number A, or part A here, it's asking us to describe what the point of intersection actually represents in this scenario. So with the purple line, you guys are seeing that we have some upfront costs, and then the costs are going up all the time because we have to pay for dough or flour or pepperoni or cheese and all that stuff, right? And so there's a line there, right? But then additionally, we start making money because we're selling pizzas, right? Well, it's at this point is the point of intersection, It tells us the break even point. Okay? It's where our costs start to become lower than the money that we're making, right? So if I start to make, as soon as I make 31 pizzas, if I go find 31, I'm now on the right side of that point. I'm making more money than my costs. Okay? And so this is like this little area here, if you will. Oops. Okay, if we zoom in on this area, that means that for every pizza to the right of 31 or 30, that turns this into profit. This is all our profit. Okay? Okay, and then if we don't sell 30 pizzas, this is where we would be losing money. Okay? So it's a break-even point. It's the point at which the two lines cross, and the lines can represent different things, right? So we can start applying this concept to all sorts of different scenarios. And we saw it yesterday with the taxis, right? So how many pizzas must be sold before there is a profit? That is, income is greater than the cost. Well, we must sell more than 30 pizzas okay. I'll open up the chat here. Does anybody have any questions about that? So again, I'm bouncing back and forth between like you'll look at the cell phone question from yesterday, plotting two lines and then figuring out where they cross. That's like the graphing way to solve these questions. But this morning's lesson provided you with the opportunity to like solve them using algebra, which is a little bit more accurate in the sense that the graphing can sometimes, like if you can imagine, I had two lines on my grid here. I'm just making this up, by the way. What happens if these lines cross in the middle of like a grid space? Now you're taking a guess as to what that answer is. And that's one of the pitfalls of graphing, okay? Whereas, if you apply this process that I gave you this morning, it will always spit out the exact answer. That's its strength, okay? And this is really why I reviewed so much of the grade 9 material from before the break, is graphing lines and whatnot, because it really lays the foundation of what's going on here, right? As soon as we start to lay two graphs on one, we need to understand what this point is actually telling us. Okay. Does anybody have any questions? Okay, so I'm just going to scroll down here and we can look at this as well. Okay. So you can imagine, just as, so Belleville and St. Catharines are two towns in Ontario. Okay, St. Catharines is actually where I'm from. And you guys know where Belleville is. It's just 40 minutes from here. Okay. They're 300 kilometers apart. Okay. So you can see right now, you can see the difference here in the distance from St. Catharines. Okay, it's 300 kilometers. That's why it's there. Okay. Graph A represents a car traveling from Belleville, right, to St. Catharines at an average speed of 80 kilometers per hour. Okay. So again, 80 kilometers per hour, if I see the word per, right, that's the slope, M. Okay. Where did he start, or where did this person start? He started 300 kilometers from the starting, like the destination, right? So my equation for graph A should look something like this, where y is the distance from St. Catharines. We should see 80x plus 300. Does anybody disagree? Okay. And then additionally, if we look at graph B or line B, this person is in St. Catharines. So they're starting, like how far they are from St. Catharines is at 0. And then they're going 90 kilometers per hour. So that means, this is again M. This would have been up here B. But this time, if they're in St. Catharines, B is going to equal 0. Right? So the equation for B is going to be y equals just 90x. Okay? So what you're going to see here is these two cars, these two people are driving. They're driving down the 401, I'd imagine, right? Or some combination of the 401 and 427 or whatever. Okay? And at some point, based on this information, they're going to pass each other on opposite sides of the highway. Well, when does that occur? Right? Well, it turns out it occurs 1.8 hours, because that's time. Time is along here, right? 1.8. And it occurs after they are both 160 kilometers from where they started. Okay. Now, I'm going to take this opportunity, because we talked about the two equations and how we developed them, which is not new information. We did a little bit of that before the break too, right? You can see from both of these two chunks of information, that's how I got those two equations. Okay. Now, I'm going to show you guys something. I don't know if you've done this before, and hopefully you can all see my screen here. Right? I'm going to go to a thing called Desmos, okay? And Desmos is like an online graphing calculator, okay? And when you go to Desmos, you guys can use this, and I'll show you how to use it in a sec. You can use this to help you find the answers for equations like this, okay? And I'll show you that in a sec. So we're just going to take a look at these two equations, right? So we click on graphing calculator. It's going to take us to this page, okay? And when you get to this page, you can type in the equations that you've found, okay? And this is, or that are given. This is like a way to kind of check if you're right or wrong, okay? So I'm going to plot these two graphs. Y equals 80x plus 300. Okay, and there's something else that I have to fix about that equation. So the catch here is, and I forgot about this, the person is moving away from the starting point. Okay, so that just means that their speed has to be negative. Okay, so we have to throw a negative in there for this to make sense. Otherwise, we're not going to get it. Okay, because they're moving away, so their speed is technically negative relative to the other one. Okay, I'm going to zoom out here. Okay. Okay, and then I'm going to plot the other one. So as soon as you hit enter, you can go y equals 90x. You can see where they cross. Okay, we're just going to try and scroll up and find where these two lines cross. It looks like right there. Move it up a little bit. Sometimes zooming in can help you out too. Should be right there. Okay, it looks like, and I think they've done this for a reason, okay? If I actually plot this and I go to find where they cross, I try to click where they've said the answer is, and it's not there. It's actually right here. So you can see how this is it's just illustrating why the graphing method is not the best method for this sort of situation, right? You can see here they said the answer is 1.8 and 160, but in actuality they've rounded it a little bit. Okay, it's 158 kilometers. Okay, 1.76 hours. Okay? So you can see how, like, graphing, you're kind of taking a guess as to what that point might be, right? Whereas if you use the substitution method from this morning up here, you're going to get that exact 1.765. And 158.82. And that might not seem like a big deal, okay, like the rounding, but that's just in this context of this question. What if we're talking about money, right? And this represented thousands of dollars, right? 1.765 rounded to 1.8 thousand, right? Like thousands, that's a bit of a difference, you know? We care about the rounding error in those situations, which is why the graphing might not be the best method. Okay, so as you guys are working on these questions, right, you can check if you don't believe that the answers are right at the bottom, or if you're doing other questions, right, you can check each of these. So if we'll plug in number 1 and see, right, x plus y is equal to 10. And if you go down and type in the second one, okay, we're zoomed out a little bit so the lines didn't come up, but we can scroll down. Okay, where do they intersect? Right here at 6, 4. Okay, so all we're doing is plotting. We're plotting lines individually, which we did a little bit of, right, before the break, and you did a lot of probably in grade 9. Okay, except we're going to put 2 lines on one grid, and we're going to see where those 2 lines cross. That's what we call the point of intersection. Okay, that's what we're after. Okay, does anybody have any questions? Okay, so I'm going to hit stop there. Okay.